Skin aging may be inevitable, but the unique microgravity environment of space may accelerate the rate of skin aging. A newly arrived study seeks to investigate the underlying molecular mechanisms that drive skin deterioration. The Colgate Skin Aging Investigation arrived on NG17 and consists of a model that uses human skin cells on a porous membrane to mimic the 3D organization of skin tissue. This study evaluates the cellular and molecular alterations associated with growth in microgravity compared to the normal aging process on Earth. The results from this investigation could help create and validate engineered tissue to protect aging skin, heal from wounds, and combat infection.
The ISS Archeological project, also known as SQUARE, is wrapping up its first test study aboard the space station. Archaeologists on Earth use a 1 meter by 1 meter shovel pit method to excavate layer by layer and reveal objects. In space, astronauts have instead taped off 1 meter by 1 meter squares in various high-traffic places throughout their home and orbit. They've taken pictures of these squares on a daily basis to reveal layers of activity within. The aim is to show how these areas change over time and to capture how the station was used day to day. Results from this study will not only preserve the daily use of the ISS for future generations, but could also be used to improve the design of future spacecraft and habitats. Work performed by NASA astronaut Rajachari and European Space Agency astronaut Matthias Maurer included the installation of jumper hoses for the thermal system. Upgrades to some of the electronics and power components on the station were also on the book for the spacewalking duo. Wednesday's EVA was the second for Chari and the first for Maurer.
Astronaut Mark Vande Hei passed Scott Kelly's record and now holds the title of most consecutive days in space by a U.S. astronaut. Vande Hei is set to come home from the space station on March 30th, giving him 355 days in orbit. Before he comes home, he answered some questions sent in on social media to reflect on his mission. Many of you wanted to know, what is he most looking forward to back on Earth?
The first thing I do when I get back to Earth, or the thing I'm looking forward to most, is just spending quiet time with my wife, having long, slow Saturdays and Sundays, just hanging out and taking life slow. I'm very, very much looking forward to that.
Imagine if farmers could get advance warnings of water stress in their crops, alerting them to changes in crop health days to weeks before they become visible. They would be able to head off those issues and decrease chances of crop losses. A new experiment heading outside the space station aims to do just that. NASA flight engineer Kayla Barron installed the Long-Wave Infrared Sensing Demonstrator, or LISAR, on the NanoRacks external platform this week. The CUBE satellite will reside on the exposed facility of the Japanese experiment module for several months. It will test a thermal infrared sensor for taking precise measurements of Earth's surface temperature and monitor water resources. This testing is a first step on the path to launching constellations of small satellites that could take measurements around the entire globe every day. This knowledge could help farmers achieve more yield and better quality crops.
A picture is worth 1,000 words, but images from the Crew Earth observation experiment have value that is beyond words. Crew members aboard the space station use a wealth of digital cameras to record how the planet is changing over time. One study used satellite imagery and data pulled from crew photographs to computationally model nighttime light. It provides a unique perspective of light spectrum signatures and the difference between outdoor lamp types, resulting in statistical maps of the relative contribution of different lamp types. You can access more than 3 million astronaut-taken Earth images online, thanks in large part to the Crew Earth Observations experiment.
Since 2017, the Advanced Combustion via Microgravity Experiments, or ACME, conducted 6 studies in which 7 gaseous fuels were burnt, and over 1,500 flames were ignited and studied. The goal of ACME was to study flammability, improve engine efficiency, and reduce pollutant emission in combustion, as well as to better understand how to prevent fires in spacecraft. Now, the Solid Fuel Ignition and Extinction Facility, or SOFI, builds on the work of ACME with a new series of investigations studying flames in new ways, such as material ignition and suppression. Launched aboard NG-17, SOFI will help NASA select materials and designs for spacesuits, cabins, and habitats. The experiment will also help NASA identify the best ways to put out fires or smolder materials in space.
Growing plants in space involves soil, which can be heavy and require a lot of maintenance. One experiment launching on Northrop Grumman's 17th resupply mission hopes to change that. The X-Roots experiment is looking to use hydroponic, or water-based, or aeroponic, air-based, techniques to reduce mass. It will allow astronauts and researchers the ability to watch the roots as they grow. Another experiment launching is called the MicroQuinn 3D experiment. It will look at the effects of a drug on breast and prostate cancer cells. They'll be using the microgravity environment to grow the cells in a 3D model, allowing researchers to get a better look. The MicroQuinn 3D experiment hopes to make researchers smarter about disease progression and drug resistance, so one day we might see new treatments for cancer patients on Earth that are more effective and have better patient outcomes.
Matthias Maurer teamed up with his crewmate Mark Vande Hei to work on the European Space Agency's experiment to develop acoustic tweezers. The duo conducted several experiment scenarios for the ultrasonic tweezer experiment to evaluate the possibility of trapping various objects, either single objects or multiple objects, in the acoustic field. The objective of the ultrasonic tweezer project is to develop acoustic tweezers that use sound to allow for remote and contactless manipulation of materials in a microgravity environment. In the experiment, an ultrasound beam is shaped so that it produces a trap from which an object cannot easily exit. By moving the beam, the object can be moved to a new position with very good precision.
European Space Agency astronaut Matthias Maurer recently printed samples from a handheld bioprinter. Bioprinting is a subcategory of 3D printing, which uses viable cells and biological molecules to print tissue structures. BioPrint First Aid demonstrates a portable handheld bioprinter that uses a patient's own skin cells to create a tissue-forming patch to cover a wound and accelerate the healing process. On future missions to the Moon and Mars, bioprinting such customized patches could help address changes in wound healing that can occur in space. Extracting an individual's cells before a mission may enable more immediate response to injury. NASA flight engineer Mark Vande Hei performed a series of tests for the Rome investigation. Rome uses the space station's Astrobee robots to observe and understand how targets tumble, and uses this information to plan ways to safely reach them. Astrobee, NASA's free-flying robotic system, is designed to help astronauts reduce time they spend on routine duties, leaving them to focus more on the things that only humans can do. A pair of small satellites called CubeSats were deployed outside the Japanese Kibo laboratory module. This release included the Light 1 CubeSat, which focuses on the detection of terrestrial gamma-ray flashes coming from the Earth's atmosphere. Another CubeSat, developed by the Georgia Institute of Technology, has experimental deployable solar panels and a deployable UHF radio antenna. The modest size, cost, and weight of CubeSats like these are increasing access to space and expanding low Earth orbit research.
On station, the crew began the Veggie Pond's validation experiment in the Veggie facility. The Veggie Pond's investigation expands on previous validation tests of the new veggie hardware, which can potentially allow crew members to grow a variety of new crops, from new leafy greens to dwarf fruit crops, in space. Tests also aim to determine and monitor microbiome population changes that are present in space-grown crops, providing baseline data for future food production efforts. Results from the Veggie Pond's investigation contribute to basic research on plant cultivation, benefiting agriculture and biomass production efforts on Earth.
Cargo Dragon is the In-Space 4 physics study. Results from In-Space 4 could share insight into harnessing neoparticles to fabricate and manufacture new materials, including medical diagnostics and thermal shields for Earth and space applications.
New science on the station will study certain bacteria and fungi and their resistance to antibiotics. Researchers in the Microbial Tracking 3 experiment use environmental surface samples collected by astronauts aboard the space station to identify, analyze, and characterize pathogen dynamics and antibiotic resistance to predict which may pose a threat to crew health. Analyzing the potential risk to astronauts on long-duration missions also benefits life on Earth, as some of the same bacteria and fungi that have adapted to the spaceflight environment are the same as other environments, like hospitals, offices, and homes.
Superalloys are metal alloys with incredible heat-resistant properties. The Turbine Superalloy Casting Module is testing a commercial manufacturing device that processes heat-resistant alloy parts in microgravity. The research of these superalloys could improve the performance of materials under extremely high temperatures, such as metals and turbine engines for aerospace and power generators. Many of us dream of what it would be like to live in space, though very few of us get to actually dream in space. While living on the space station, the crew will experience sunrise and sunset 16 times a day. This can cause disruptions to their circadian rhythm and ability to sleep. The DREAMS experiment aims to study this change in the astronauts' sleep patterns and to examine how their minds and bodies adapt to sleeping in microgravity. ESA astronaut Matthias Maurer will be the next crew member to participate in the DREAM experiment. Maurer will be wearing a sleep headband for several nights that's fitted with dry electrodes and sensors. The headband will observe how he adapts and how his sleep patterns change while in space. The impact of microgravity on sleep is a key challenge facing future long-duration missions to the Moon and Mars. Clean in space the same way we do here on Earth. They have daily hygiene activities to brush their teeth, comb their hair, and wash their hands and face. And they even give each other haircuts.
Great job with this. I'm thinking about a third career in hair cutting.
The astronauts wipe their bodies clean using a wet towel and wash their hair by using waterless shampoo. After washing, they will use dry towels to dry themselves off. They also have to complete weekly housekeeping tasks on board the ISS, where they vacuum all air vents and filters and smoke detectors. Then they disinfect and wipe down surfaces that are frequently touched throughout the day by the crew. Areas like handholds, the galley and its tables. Typically, there are 6 hours a week spent on keeping their station home a clean and safe environment.
Installation began of the flow boiling and condensation experiment. The goal of this new facility is to collect data about two-phase flow and heat transfer in microgravity. We'll need to generate more power during longer space missions, meaning the heat produced needs to be dissipated. Two-phase thermal management systems reduce the size and weight of the system and make heat removal more efficient. This experiment is yet another way the work being done on the space station continues to prepare us for future destinations deeper into the solar system.
Studying a new technology that could keep astronauts and equipment cool while working outside the orbiting laboratory. The Spacesuit Evaporation Rejection Flight Experiment, or SERFI, uses evaporation of water for cooling, and researchers are evaluating the technology's effect on contamination and corrosion of different spacesuit materials. Crew members recently completed several samplings of water to send back to Earth for analysis. This research supports development of spacesuits for future exploration missions.
Studying the use of magnetic fields to assemble tiny structures from particles suspended in a liquid took place this week with the InSpace 4 investigation. InSpace 4 looks at how colloidal structures change the properties of assembled material, such as its mechanical response to or interaction with light and heat. Microgravity offers a unique opportunity to observe assembly in ways and over timescales not possible on Earth. Results could provide insight into how to harness nanoparticles to fabricate and manufacture new materials. This work could also advance the manufacturing of materials on Earth for applications such as thermal shields, sound dampening devices, camouflage, medical diagnostics, and possibly even active cloaking materials.
One of the major areas of scientific research on the space station is on the astronauts' own bodies. Some of the first experiments they perform help determine their acclimation to the microgravity environment, testing functions like dexterous manipulation, effects on the central nervous system and depth perception, changes in bone and muscle mass due to the release of phosphates stored within, and how an astronaut's ability to visually interpret motion, orientation, and distance may be affected by the spaceflight environment. These studies help us better understand how to prepare for and mitigate issues on long-duration spaceflights, and also provide insight on how to improve similar conditions for people on Earth.
As we prepare for long-duration missions further from Earth, it will be important for astronauts to grow their own food. Currently aboard the International Space Station, crew members are seeing the fruits of their labors in the advanced plant habitat.
NASA astronaut Mark Vande Hei harvested the first crop of 4 pepper plants growing in the advanced plant habitat aboard the International Space Station. The Plant Habitat 4 experiment is one of the most challenging plant experiments on the orbiting laboratory to date, in part because of the long germination and growing times of the peppers. NASA astronaut Shane Kimbrough initiated the experiment on July 12th, and the peppers grew for 109 days before the crew got to try the spicy treat. The Crew 3 astronauts will continue caring for the pepper plants and will conduct the final harvest of peppers later this month. Learning how to grow crops in space is still one of the key components in nutrition for future space travelers. Fruits and vegetables can supplement astronauts' diet with key nutrients like vitamin C and vitamin K, which future explorers will need during long-duration deep space missions.
Launched on STS-128 in August 2009, the Light Microscopy Module, or LMM, has contributed to scientific discoveries, including improvements in biomedical device technology, while also improving our understanding behind the phenomena of earthquakes. Through its 40 experiments conducted over 11 years, LMM has been instrumental in helping scientists and engineers understand the forces that control the organization and dynamics of matter at microscopic scales.
The Japan Aerospace Exploration Agency investigation anti-atrophy tests the ability of biomaterials to inhibit muscle atrophy in microgravity. Researchers plan to compare two types of cultures returning to Earth, and results may lead to the production of pharmaceuticals to prevent muscle atrophy for astronauts in space and the elderly on Earth.
Based on the current exploration, environmental control, and life support systems, and lessons learned from its nearly 20 years of operation, the 4-bed CO2 scrubber includes mechanical upgrades and an improved, longer-lasting absorbent that reduces erosion and dust formation. This technology could improve the reliability and performance of carbon dioxide removal systems in future spacecraft, helping to maintain the health of crews and ensure mission success. Did you know that alternative reality and virtual reality serve as helping hands aboard the space station? Here on Earth, experts are lending a hand to the astronauts. Both virtual reality and augmented reality serve as support for various activities aboard the space station. One of these is T2AR, which uses augmented reality to help crew members inspect and maintain the space station's T2 treadmill. Acting as a smart assistant, the AR application runs on tablets or headsets, interpreting what the camera sees and what the crew member does and suggests the next step to perform. Time perception is an ongoing ESA experiment to investigate the perception of time to humans during spaceflight. Crew members wear a head-mounted VR display, listen to instructions, and use a finger trackball connected to a laptop to respond.